Hi and welcome back to my channel. Today is cheater amp dyno time. I'm talking about the MTX Thunder 225HO, which is a cheater amplifier from the mid-90s. The amp is rated 25 watts into a 4 ohm load, 50 watts per channel into a 2 ohm load, 100 watts per channel into a 1 ohm load and 200 watts per channel into a half ohm. With the great support of Jan from whatsupaudio.com, it was possible to present this video to you. You should check out his web shop. This amplifier I tested will be available in his web shop for a nice price in my opinion. WhatsUp Audio is located in the Netherlands but offers international shipping. The features of the amplifier are really simple. On this side you have the power connections for ground, battery plus and remote. You have 3 fuses, 30 amps each, and the speaker connectors. On the other side you just have the RCA inputs, also RCA outputs, and just 2 knobs for the gain. That's it. Does it need more to cheat all the others out? Let's see on the dyno.
I have a 8 ohm monoload connected to the amplifier and I'm starting with a 1 kHz continuous power test. So we get clipping. Let's go back. That's not nice. Let's take this. And I have a peak voltage of 41.4 volts. The amplifier delivers bridged mono around 110 watts. That means I have almost 55 watts per channel into a 4 ohm load of continuous power, both channels driven. And here is a 50 Hz continuous power test. I'm going to reduce. That makes it look a little bit better. Oh, that was way too much. We can squeeze out some more. And I have a peak voltage of 40.8 volts. This test was not very accurate and now I took some more time, and I also have, as you can see here, 41.4 volts at 50 Hertz. And now I have also 55 watts per channel into a 4 ohm load, both channels driven with 50 Hertz. Dynamic power test 1 kHz. I found out that I don't have dynamic headroom. The signal looks like this. That's a burst of 20 milliseconds. I catch one burst. That's it. I'm always looking at the last cycle. And you see it goes a little bit into clipping, and that means we have also around 41.4 volts, so there's no dynamic headroom. And I jump directly to the 1 cycle test. That means output power for 1 millisecond, and you can see we also have 41.4 volts. And if I try to squeeze out some more, it looks like this. So that's not valid. So that means I also have 41.4 volts. There's absolutely no dynamic headroom. How many amps is the amplifier pulling? If tested 8 ohms mono, that means both channels into a 4 ohm load continuous power test 1 kHz. So I got 16.8 amps. I calculated an efficiency of around 45%. Now I'm switching to the 2 ohms per channel tests by connecting a 4 ohm mono load to the amplifier. Continuous power 1 kHz. I try to catch the cleanest output voltage I can get. This is ugly. I think I can use this one. So I calculate with 41.1 volts. The amplifier puts out around 216 watts. Bridged mono 4 ohms. That means I have 108 watts into a 2 ohm load per channel, both channels driven into full power. And here's a continuous power test, 50 Hertz into a 2 ohm load, both channels driven. It gets dirty. Still dirty. That's okay. And I have a peak voltage of even a little bit more, 41.4 volts, 110 watts into a 2 ohm load per channel, both channels driven. That means 220 watts, mono 4 ohms. Also no dynamic headroom into a 2 ohm load per channel. And the amplifier pulls 33.3 amps. Let's take 2. The MTX also has an efficiency of 45% into a 2 ohm load. Now the amplifier is connected to a 2 ohm mono load, that means 2 1 ohm resistors in series, bridged mono to the amplifier, so I'm testing 1 ohm per channel, both channels driven into full power. And as always, 1 kHz first. So I got a peak voltage of 40.2 volts. Bridged mono into a 2 ohm load, the amplifier delivers 404 watts. That means I got 202 watts into a 1 ohm load per channel, both channels driven. And the next continuous power test was a 50 Hz input signal. That's good. And we have a peak voltage of 39.6 volts, 196 watts into a 1 ohm load per channel, both channels driven. And it's 59.1 amps. I calculated an efficiency of around 47%. And it gets ugly, and we are also at around 40 volts. So that means the amplifier has almost no dynamic headroom. And now I'm testing with a 1 ohm mono load, bridged mono to the amplifier. That means I test a half ohm per channel, both channels driven into full power. Continuous power test, 1 kHz into a half ohm per channel, both channels driven. And I got a peak voltage of 37.2 volts. The amplifier delivers 345 watts into a half ohm per channel, both channels driven. Continuous power test with a 50 Hz input signal. So I got a peak voltage of around 37.2 volts. That's impressive. Even with a 50 Hz input signal, the amplifier delivers around 345 watts. Exactly 345.9 watts into a half ohm per channel, both channels driven. Let's have another look at the amplifier's current consumption. Into a half ohm per channel, both channels driven. 1 kHz. 109.1 amps. 2. So I got 14.43 volts. When I'm pulling more than 100 amps, the amplifier has an efficiency of 43.9%. 1 ohm mono, I have no dynamic headroom. Now I connected 2 1 ohm resistors in parallel, bridged mono to the amplifiers. I'm testing output power into a 1/4 ohm per channel, both channels driven. I'm not going to test continuous power into a half ohm mono. I'm just doing dynamic power testing because first thing, if I don't want to hurt the amplifier, and I'm sure that my fuses will trip. Try to catch a burst, and I always check the last cycle, and then I increase my input signal. We go straight up to clipping. Need to put my trigger a little higher. Still no clipping. Oh, there we get dirty. Try to reduce, I try to fine tune it. Negative waveform looks dirty. That looks okay. I stop the test. And we have an output voltage of, let's say 30 volts. 450 watts into a 1/4 ohm, both channels driven with 20 cycles. That was 1 kHz dynamic power test. And here's another try. That's my burst signal. Last cycle. And we can calculate with 31.8 volts. That means the amplifier does not deliver 450 watts with 20 cycles, it delivers 505 watts. Now I'm testing output power for just 1 millisecond with 1 cycle, 1 kilohertz. And we have a slightly higher output voltage. We can calculate with 33 volts. Bridged mono half ohm, the amplifier delivers 1089 watts. That's 544.5 watts into a quarter ohm per channel, both channels driven. MTX Thunder 225HO on the dyno with the lowest impedance test I ever did. So I have connected 0.33 ohms mono to the amplifier. That means I test 0.16 ohms per channel, both channels driven. And I start with a 1 kilohertz burst test for just 1 millisecond. And let's have a look if the amplifier goes into protection or can put out some voltage. And we have a signal. I increase, it goes dirty. Try to fine tune it. Okay, let's say this is okay. We have a voltage off. Let's calculate with 30 volts. For just 1 millisecond, the amplifier puts out 1350 watts into a 0.33 bridged mono load. 675 watts into 0.16 ohms. 0.16 ohms per channel, dynamic power test, 8 milliseconds. I observe last cycle, of course. Oh, protection. Let's take this. So we got 24 volts. Bridged mono 0.33 ohms. The amplifier delivers 864 watts. That means we have 432 watts into 0.16 ohms per channel, both channels driven with 8 milliseconds. This little guy here is one of the best cheater amplifiers I ever had on my bench.
If you like this video, you should also check out all my dyno videos, which feature lots of amplifiers from the 90s. Thank you very much for watching and see you next time. Bye bye.